our first study island assignment. We'll have two topics, the first of which is comparing and ordering real numbers. The second is dealing with domain and range and different functions. A couple of things here to think about with comparing and ordering real numbers. When you compare numbers with decimals, we need to do the following things. First, check to make sure that the number to the left of the decimal, compare those two. Because if you can go no further than that sometimes. For example, if we have 54.72 and we're comparing it to 58.59, well, all we have to do is compare 54 and 58 right here and know that 58.59 is greater than 54.72. You might know that right then. So keep that in mind. But many times that's not going to happen. We'll have something like 56.27 and we'll have like 56.29. Okay, and we'll be asked to compare these. Well, we check 56 and 56. Those are the same. Then we have the decimal point. So we check the number to the immediate right of the decimal point. 2 and 2. Well, those are the same. Okay, so we go to the next one. 7 and 9. Well, 9 is greater than 7, so that makes 56.29 greater than 56.27. So that's how we do that. Okay. If we're working with fractions, we have two options. First, you check and make sure we have a common denominator, and then whichever number in the numerator is greater is the greater number. Okay. The other option is to change that fraction to a decimal by dividing, and then do the same as we did up top with the decimals. So pretty straightforward, things that you've done before, I'm sure. Negative numbers kind of throw in a little bit of a twist. Okay. Just remember the greater of two negative numbers is the one that is closest to 0 on the number line. So if this is my number line, and here's 0, I have the number -8, and I have the number -3. Well, if I compared 8 and 3, 8 would be greater than 3, but these are negative numbers. -3 is closer to 0 than -8, so it would be -8 is less than -3 is what we would have there. Okay, so again, whichever number is closer to 0 is the greater value. You can kind of think of it in terms of money. You would rather owe somebody $1 than owe them $10. You'd rather be -$1 in the hole as opposed to -$10 in the hole. If you come across irrational numbers, put them in decimal form and treat them the same way as other decimals. Pretty straightforward with that. The process of ordering numbers, when you're asked to put them in order from least to greatest or greatest to least, the very first thing you have to do, and this is very important, is make sure they're all in the same form. And we highly recommend putting these all into decimal form. That way they're all the same, and we can do different things as far as that goes and compare them the same way we compared other decimals. So once you have those in all the same form, then you need to make sure you answer the question that's asked. You may be asked to order them from least to greatest, in which case you would put the lesser number first and each subsequent number. Sometimes they ask for the greatest to least, in which case you would need to put the greatest number and then go down from there. I know that sounds very obvious, but we need to make sure we pay special attention to the instructions and answer the question that they're asking us for. Because both of those will be least to greatest and greatest to least will both be one of your 4 answer choices. I can guarantee you that. Some inequality symbols, basic things. The point goes to the lesser number. So right here, the point goes to A, so that means A is less than B, or it could also be read as B is greater than A. Here the point goes towards B, that means A is greater than B, or B is less than A. We can go either direction, okay? But know that the point goes to the lesser value. The open end goes to the greater. Okay? Try not to make that careless, not careless, but unnecessary mistake there, just based on not knowing the symbols. Couple of examples, we just did those already, so make sure you have those written down, the ones that we gave you going through there. The other topic, domain and range. Okay, a relation is any set of ordered pairs. Okay, and these will have domains and ranges. They'll have a domain and a range. Okay, the domain will be the set of all x values, and those will also be referred to as the input values. So those are your x values, whether it's on the x-axis, whether they're in ordered pairs. There could be in a multitude of different ways, but the x values will always be the domain. Likewise, the range is the set of all y values, and those are referred to as the output values. So anything that's an output or related to y there will be part of the range. A function will also come into play here. Is a relation is considered a function if and only if each input goes to only one output. What does that mean? Well, that means each x goes to only one y. Okay? Only one y. So for example, I have my x and my y. Let's say I have 1, 2, and 3, and I have A, B, C. And 2 goes to B, 1 goes to C, and 3 goes to A. Each x goes to only one y. That's a function. Okay? I'll give you one that's not a function. I'll put it in red so it kind of stands out that way. 1, 2, 3. Those are my x's. And then let's say I have A, B, C, D. And I have 1 going to C, 2 going to B, and then I have 3 going to A and D. Well, this is not a function, and that's because 3 is going to A and D. So that fails the function test. But it would still be a relation. And that's our biggest example. And we'll answer a few more questions on those if you have them on Monday during Study Island time.